Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the lectures on computer vision. In the last lectures in CNN, we actually saw how we could prepare the model and how we could prepare the dataset as well. So we were training our model and I told you that we'll wait for 10 epochs to see what the final result is. But while we were actually training our model, what I saw was that since I was using a non-GPU version of the Google Colab, so this was taking a lot of time for it to actually get trained on a one particular epoch, that is around like 30 minutes for one epoch to be completed, and hence running on 10 epochs would actually would be such a tedious task, and the accuracy was not increasing as the way I wanted it to. Therefore I thought it's a good idea to use Google Colab in this case, since we could actually use the GPU support over there. So I went on to Google Colab and created the same model over here. Just that I created some changes so as to increase the accuracy and learning from my previous mistakes that I have done. What I did was that I increased the target size of the image size to 128 cross 128, and I also increased the batch size to 100 so as to enable a faster processing of the images, and 100 because Google Colab could easily support a batch size of 100 images. And then I also added batch normalization in my model and ran the model for 30 epochs to see how is it actually performing. So I hope it's the same training data, validation data, and 30 epochs. And after that, when I plotted on the model using what I did was that I actually saved this into a variable known as history or hist, and then while plotting I called plt.plot hist.history of accuracy and hist.history of validation accuracy. So if I were to extend this plot to give you a better idea, so I could have actually plotted at a legend over here, and then plt.plot plt.x label number of epochs, and then plt.y label is number of or accuracy, actually basically accuracy. So if I were to if I were to tell you how it's actually performing, so you will see that plt.legend is not appearing over here. I don't know, it should have actually appeared over here. And okay, in plt.legend you actually have to pass into what legend are you looking upon. So the legend that I am looking upon is training and validation. So train and let's say validation, and let me just run this over here again. And yeah, as you can see, the legend is now appearing, and you can see that okay, validation accuracy is quite good. It's quite close to 100%. So but the validation accuracy is not good. It's decreasing sometimes. It's an increasing, decreasing, and increasing sometimes. So it's not constant. A good example that our model might be overfitted, not exactly confirmed, but yes, it means if you actually see over here, you will actually see that the pattern that okay, it's sometimes giving us a very high accuracy and sometimes giving us a very low accuracy and all of that kind of stuff. There's a way to deal with that as well. I will explain to you in one of the subsequent lectures on how to use callbacks and all of that stuff to actually stop this problem. But anyhow, since we're learning over CNN, our idea is that the validation accuracy is not what we expected. And if you see at the validation loss as well, sometimes the loss is picking up a curve at a very high point and then decreasing. So not that good. Validation loss is not that good as well, whereas training loss is actually perfectly fine. So this is a clear cut case of overfitting. So now I actually introduce you to a term known as overfitting and underfitting as well. So overfitting happens when the model, instead of training itself, actually learns rote learns the things. So the model should basically train and learn by itself, right? But instead here it rote learns that okay, if I see this particular image, then this corresponds to this category of disease as such. So it is actually rote learning and not training and learning. So this is why when any outside image comes or the image on which it has not been trained, it will perform quite poorly on that. It's quite similar if you look at an example, there is one student who can actually perform very well on one set of questions because he has practiced them a lot, but even if you change the value of a variable to even a little bit, he could not actually do what is actually expected from him, right? So this is a very practical scenario of overfitting in like machine learning models, or overfitting in general maybe. And then underfitting is basically just the opposite over here. But basically this model is just overfitting, and we could have actually created a better model to actually see if like this could reduce or not. So maybe I could have added another batch of 128 over here. Like when I change these variables, like I need to change the input shape over here as well. So when I change the model structure, so this could have changed as well. So I could have added another layer and all of that kind of stuff. But basically to let you know like what we are doing. So this is like not giving us a very good accuracy. But anyhow, I hope you understand like the concepts of CNN, like how CNN is done, how model is trained, and how we can actually get the results. So we'll come back with the like I will make another video over it, like we will increase the accuracy even further and like create a new model type of thing, and then everything would work actually perfectly fine, and the loss would comparatively decrease as well. So see you in the next one. Thank you.